we are going to test this series for convergence. So since we have factorials involved, ratio test will be a good strategy. So we shall calculate the limit of this ratio of every term with its previous terms. So the limit of these ratios as n goes to infinity, and here an is the nth term, which in this case is this term here. So subsequently, our n plus 1th term would be what? The next term that we are looking at is, instead of n, everywhere we will have how much? N plus 1. So here for n, we are going to replace it by n plus 1, and the same thing here. Okay, and so what that will do is that this term becomes how much? This would be just distributing these here. So multiplication by 2 will give us this, and here for some reason n got erased, I'm sorry, and this will become, and I don't know where that n came in from. Okay, I see I mistyped it here, I apologize for that. So right here, so we'll distribute 4 in here, and there is one extra bracket. So first let's just go ahead and erase this 4. So that's what this is going to become. So now when we calculate an plus 1 over an, what will happen is that we are, or what is happening, that we are dividing this fraction by this fraction here. So that will be a complex fraction. So this fraction is simply going to flip, and this one will stay as it is. So what we got next is that we have a factorial of 4n going upstairs, and the remaining terms coming in the denominator. Okay, and I'm just simply going to quickly do some algebra. So I will go ahead and align the like looking terms over the top of each other, so that it becomes easier to simplify them. So we got this, and then times. Okay, we have next we have what? 2n plus 2 factorial divided by 2n factorial. Okay, and then at the end what we have is 4n factorial divided by 4n plus 4 factorial. Okay, so here is what we have. Okay, so if we just go ahead and further just expand the products, let's see what we shall get. So we have this. I'm just taking these all to the next line, I'm sorry. Okay, so here we got this. So notice that here we will first, in this portion, we got n plus 1, okay, and then times what? Factorial n. That's what the factorial n plus 1 is here. Okay, and this whole thing is squared. And in the next term, what do we have? We got this 2n plus 2 factorial, and downstairs we have 2n factorial. So we'll start expanding it, and then we'll stop when we have, here we have an extra bracket. All right, okay, let me just put this here and erase this. So, well, in the denominator I have factorial 2n. So in the numerator, when I'm expanding it, I get 2n plus 2 times 2n plus 1, and then times 2n factorial. Okay, so let's write it down, times, and this way it becomes easy for me to write. Okay, so this is 2n factorial that comes up there. And then at the end, what we are going to do is this time we have to do the expansion in the denominator. This is bigger than the numerator. So I think we just have quite a few steps to write here. So we got 4n plus 4, okay, times 4n plus 3 times 4n plus 2, and then times 4n plus 1, and then after that we get 4n factorial. That will be cancelled by the 4n factorial in the numerator. So what we have is, let me just rewrite that. Okay, all right, so we got this, and then I'm just going to bring this all here, and then I'm going to do the cancellations. Okay, so here, so when we look at this whole thing, sorry, I forgot to close my brackets here. Let me do that, and this is an extra bracket. Okay, let me see if there is any malfunction like that there. No. Okay, I was just looking at keyboard, looks like. Okay, so here is what we have, and now we can see this. First, there's an extra bracket here, sorry, and then should have this. And then you can see that we can cancel these two here. These guys cancel and these cancel, okay? So after they all cancel, what we get is this. And I don't know why I made too many typos or mistakes or whatever you want to call it. See, when I square the quantity inside, both the quantities will be squared, okay? Or maybe I'm trying to rush it too much, I'm sorry. But anyways, so here the final outcome will be n plus 1 whole quantity square, right? And then we will have times, okay, these guys here, okay, so, and then we got what? All these, or all of these rather. Okay, so if you look at the ratio finally, what you have is that you have this as the simplified portion of the ratio. And if you are calculating the limit as n goes to infinity, you have infinity over infinity form. But here you can see in the numerator and denominator, at both the places, we have polynomials of degree 4. And what will be the coefficient of the leading term in the numerator would be this 2 times 2 is 4. And in the denominator, the coefficient of n to the 4 will be 4 times 4 times 4 times 4. So what will happen is that this will go to simply 2 times 2 divided by what? 4 times 4. I'll just write instead of 4 to the power 4, 4 times 4 times 4. Okay, and so this limit will become how much then? This will simply become, I mean, we can do cancellations or let me just erase that first, all that here. Okay, thank you. Okay, so right here, so we have 2 times 2, so 4 times, so we got what? 1 over, after the cancellation, 4 times 4 times 4, that is 1 over 64 is the limit of the ratio test here. And since this one is less than 1, we know we can conclude that the infinite series converges. Okay,